Good evening. This is Mrs. Plovic and thank you for joining me. Tonight we're going to cover section 10.2 over stem and leaf plots, frequency tables, and histograms. Our objective for this evening is to organize and display data using stem and leaf plots, frequency tables, and histograms. Please open your notes to section 10.2 and follow along. You'll notice as we go through the notes that there are blank spaces. Please fill them in as we go along. Remember, at any point during this presentation, you can stop it, pause it, go back and re-listen, or wait till the end and go back and listen again. Let's go ahead and get started. Stem and leaf plots. What is a stem and leaf plot? Well, stem and leaf plot arranges data by dividing each data value into two parts. For example, the data value 23 would be divided into 2 and 3 as shown as 2 vertical bar 3. That is your first blank in your notes, so please fill that in, 2 vertical bar 3. Another example, the data value 87 would be divided into 8 and 7 as shown as 8 vertical bar 7. But what would we do if we had 3 numbers? Where would we divide that? Well, the data value 351 would be divided into 35 and 1 as shown as 35 vertical bar 1. The furthest number on the right is always going to be on the right side of your vertical bar. All the other numbers will be on your left. The first numbers are called the stems and the second numbers are called the leaves. That's where they get the name stem and leaf plot. In 2 vertical bar 3, the 2 is the stem and the 3 is the leaf. And in 35 vertical bar 1, the 35 is the stem and the 1 is the leaf. Let's take a look at an example. Use the following data to make a stem and leaf plot. The very first thing you want to do is find the smallest and the largest numbers in your data set. In this example, the smallest number is 21 and the largest number is 47. Therefore, our stems would be 2 and 4. The first numbers, 2 and 4. However, we do not want to omit any numbers in between. We want to include all the numbers that are in between 2 and 4. Thus, in our stem and leaf plot at the right, we will enter a 2, 3, and 4. Go ahead and fill this in on your notes. Put the stems 2, 3, and 4. Now, let's go ahead and let's enter the leaves. What are the leaves? Well, the leaves are the second numbers in this case. So if we look at the 2's, what numbers have a stem of 2? Well, here's a 21. Here's a 29, here's a 21, here's a 28. But you want the leaves to go in order from smallest to largest. So our smallest numbers are 21, and we have 2 of those, so we're going to include 2 1s, followed by an 8, and then a 9. That makes up our 21, 21, 28, and 29. Now we're going to go to our stem of a 3. We have a 35, a 33, and a 39. Again, we've got to go from smallest to largest, 3, 5, 9. And finally, we look at our stem of a 4. Our leaves are going to be 0, 4, and 7 in that order because we have a 40, 44, and 47. Another example of a stem and leaf plot is called a back-to-back stem and leaf plot. We can show 2 sets of data in a single stem and leaf plot. For example, Bob and Ron went bowling and got the following scores. Please notice that these are triple-digit scores. Create a back-to-back stem and leaf plot. The smallest number here is 134 and the largest number is 168. So in this case, our stems would be 13 and 16, but remember we need to include every stem in between, don't omit any, so that would be 13, 14, 15, and 16. In a back-to-back stem and leaf plot, the stems will be right in the middle of the plot with Bob's leaves on the left and Ron's leaves on the right. So there's Bob and Ron, there's our stems, 13, 14, 15, and 16 right down the middle. Let's take a look at Bob's numbers. Bob's numbers go out to the left. So I have 134, 137, 144, 150, 160. Ron's numbers are going to go out to the right. He doesn't have any in the 130s, 148, 149, 153, 157, and 160. Notice that the numbers always go from smallest to largest on both sides. Note that both sets of data are shown and that you can compare and contrast them easily. Now we're going to go on to frequency tables. Again, if you'd like to pause at any time and go back and watch that, you are free to do so. The frequency of a value is the number of times it shows up. Go ahead and fill in the word frequency in your notes. A frequency table shows the frequency of each data value. Sometimes, instead of individual values, the data is divided into intervals and the frequency of each interval is shown. Let's take a look at an example. In example 1, the following data is displayed in the frequency table below it. We have scores, multiple scores listed, so let's find the smallest one up through the largest one and list all of them in between. So for our scores here, we've got 1, 2, 3, 4, 5, 6, and then to the right we're going to write how many times we see that score. So I see a 1 twice, I see a 2 4 times, I see a 3 2 times, and so forth. Example 2, the scores for the algebra test are listed below. Make a frequency table using intervals. Okay, so now we're going to do intervals. Take a look at the scores on the algebra test. Instead of listing all these individually, we're going to create an interval. What I'm going to do is I'm going to take a look at the smallest score and the largest score and what scores are in between, and I'm going to create an appropriate interval based on the data set. In this case, we break the scores down in intervals of 10, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. After you figure out your intervals, the rest is pretty easy. We're going to go ahead and create tally marks on this frequency table. So I just go through and I start with 78. I put a tally mark where that interval falls in between the 70 and 79, and then I go through and I cross it off. Then I go on to 92 and I put a tally mark there and cross it off. When you have a large data set, the tally marks are very helpful. However, you still want to go out and write the number out to the right hand side. So like for the interval 60 to 69, we have a 3, 70 to 79, 6, 80 to 89, 6, and 90 to 99, 5. Next, we're going to take a look at a histogram. A histogram is a bar graph that shows the frequency of data divided into equal intervals. In a histogram, the bars must be of equal width and should not touch. You shouldn't have any overlapping. Now we're going to use the data from the previous frequency table to make a histogram. So let's take a look at that previous frequency table. And let's create a histogram based on this. Here's an example of one. There are a couple things that I'd like to point out here. One, make sure you've got a title on your histogram. Tell the reader what they're looking at. In this case, it's algebra test scores. Another thing that's equally important is to make sure you label your x-axis and your y-axis. You also have the intervals listed below here and the number of frequency up here. And we also have a key which tells the reader what each color represents. In this case, the blue bar represents the 60 to 69 interval, the red bar, the 70 to 79, and so forth. The last thing to do is to draw your actual bars. Again, the bars must be of equal width and they should not touch. They should touch, but they should not overlap. So if you'll notice, for the blue, we go up to the frequency of 3 and we fill that bar in. Then next to it, and right next to it, touching it but not overlapping it, we're going to go up to the 6 and fill that in, and so forth. The last thing we're going to talk about today is cumulative frequency. Let's go back to frequency tables and add another column that is called cumulative frequency. Cumulative frequency is simply adding up the frequencies as you go along. Let's take a frequency table that we had before and add a third column for the cumulative frequency. This should look familiar in addition to the third column out to the right. The scores 1 through 6 stay 1 through 6. The frequencies, however, are what we're going to add up on the right. So for score 1, the first entry here, we're just going to move the frequency over to the 2 because we have nothing to add that first entry to. But as we go down to the second entry, we're going to take the 2 that we already have and add it to the 4 to get 6. Then add the 2 to it to get 8. Add the 0 to it to get 8. Add 4 to it to get 12, and add 1 to 12 to get 13. That is the conclusion of our notes for 10-2. In summary, I would like to say that stem and leaf plots, frequency tables, and histograms all show how often a data value or range of data values occurs. A benefit of a stem and leaf plot is that it shows what the individual data values are. A histogram gives a quick visual to show where most of the data lies, but it does not reveal the indicated data values. Please go back and make sure that you filled in all the appropriate blank spots. And again, if you need to take a look at this again, feel free to go back and replay it at any time. Thanks so much, and I'll see you in class tomorrow.